In today's lesson, we'll continue solving exponential equations and equations with logs. Our objective will be to solve equations using the inverse properties and properties of logarithms. I know you'll be glad to hear that there's no new material for us to cover today, so what I'd like for us to do is work through 7 examples together. If you're fluent in solving logarithms at this point and you don't need this, that's fine. If, however, you're still struggling with this, these 7 examples could really help you nail down the methods for solving exponentials and logarithm equations. So let's begin with example 1. I have 5 times 1.2 raised to the x power plus 1 is equal to 26. We'll always start by getting rid of those things that are added or subtracted and then multiplied or divided. So let's begin by subtracting 1. That gives us 5 times 1.2 raised to the x power is equal to 25. I'll now divide both sides by 5. I'll get 1.2 raised to the x power is equal to 5. At this point, I now see the x in the exponent, and I know that I should take a log. I will take a log base 1.2 of both sides. So that'll give me a log base 1.2 of 1.2 raised to the x power is equal to a log base 1.2 of 5. On the left, since this and this match, I'll just get x is equal to log base 1.2 of 5. I'll now need to apply the change of base formula to the right-hand side. Remember, that'll be log base 10 of 5 divided by log base 10 of 1.2, which I can do on my calculator. And I'll end up with x is approximately equal to 8.827469. Let's look at our next example. I encourage you to stop the video and see how many of these you can work on your own. 2.5 e raised to the negative 1.2x is equal to 1. I'll begin by dividing both sides by 2.5. That'll give me e to the negative 1.2x is equal to 0.4. I now need to take a log of both sides, but it's a natural log, and I know that because this is an e. So I'll do an ln of e to the negative 1.2x is equal to ln of 0.4. Once again, I have a log of e, so I'll get negative 1.2x is equal to the natural log of 0.4. I can evaluate this side using my calculator, and I'll get negative 1.2x is approximately equal to negative 0.916291. Divide both sides by negative 1.2, and I get x is approximately equal to 0.763576. Our next problem is log base 2 of 4x is equal to 2 minus log base 2 of x. What I need you to notice here is that there are logs on both sides of the equation. What we'll want to do is gather those together on the same side. So my step will be to add this to both sides. When I do, I get log base 2 of 4x plus log base 2 of x is equal to 2. I need you to remember some of those properties of logs now. We have logs that have the same base and they're added. So what can I do? Well, I can multiply those together and I get log base 2 of 4x times x. Remember, this is the part I multiply right there. Is equal to 2. When I multiply that, I get log base 2 of 4x squared is equal to 2. I'm now in a position to be able to exponentiate. I see a log, so I'll use exponentiation. Because the base of the log is 2, I'll exponentiate using a 2 on both sides as the base. This will then become the exponent for the left, and this is the exponent for the right. That leaves me with 4x squared is equal to 4. X squared is then equal to 1. And remember the principle of square roots that we used earlier? X is then equal to plus or minus the square root of 1, which is just 1 or a negative 1. But I do need to remind you of one more thing. Logs of negative numbers are undefined. So x is equal to 1 is the only solution. Let me make sure you understand what I said by that. If I took these answers and plugged them back in up here to see if they worked, the minute I tried to take the log of a negative 4 right there, I can't do that. So this answer right here can be ruled out. The function will be undefined there. So the only answer is this one. Let me make sure you understand. You only do this when your original problem was a log problem, because that's the situation where when you get a negative answer and you try to plug it back in, causes you problems. If it's not a log problem, negative answers are fine. But if it started out originally as a log, then I need to be careful with those negative answers. Our next problem is 5 raised to the 3x power is equal to 5 raised to the 1 minus 2x power. Well, if you just looked at the left-hand side, you would say that I need to take a log base 5. Well, that's true, and I want to do it on both sides. Log base 5 of 5 to the 3x is equal to log base 5 of 5 to the 1 minus 2x. Once again, these match, so I get 3x. But look what happens on this side. These match, so I get this. So my next line is 3x is equal to 1 minus 2x. If I add 2x to both sides, I get 5x is equal to 1, or x is equal to 1/5. Our next problem is log base 10 of 2x squared is equal to 2. Because it is a base 10 log, I need to exponentiate using 10 as the base. So 10 raised to the log of 2x squared is equal to 10 raised to the second power. On the left side I get 2x squared, and on the right side I get 100. If I divide both sides by 2, I get x squared is equal to 50. Therefore x is equal to plus or minus the square root of 50, which means x is approximately equal to plus or minus 7.071068. Our next problem is log base 2 of 3x minus 2 is equal to 4. I'll exponentiate, and this time I'll be using 2 as the base on both sides. So I'll have 2 raised to the log base 2 of 3x minus 2 is equal to 2 raised to the 4th power. On the left I get 3x minus 2, and on the right I get 16. If I add 2 to both sides, I get 3x is equal to 18, or x is equal to 6. And the last problem we'll look at today is 4 raised to the x minus 1 is equal to 3 raised to the 2x power. Now this one is a little more difficult than anything else we've done, and the reason is this. You'll notice I have different bases on each side. If those bases match, it's not a problem. When they don't, it gets a little bit more difficult. So let's start, and I'm going to choose to use this base for my log. So we'll take a log base 4 of 4 raised to the x minus 1. But you need to remember, on the right-hand side, you still have to take a log base 4. You must do the same thing to both sides of the equation. You can't take a log base 4 over here and a log base 3 over here. So over here I have a log base 4 of 3 raised to the 2x power. Well, on the left-hand side, that comes out really nicely to x minus 1. On the right-hand side, I need to remember that property of logarithms that says I can pull this out in front and multiply by it. Well, that's the step I'm going to do. So I get 2x times log base 4 of 3. I want you to notice right here, that's not going to be a pretty number, but it is just a number. So let's go ahead and calculate that using the change of base formula. So I'll have x minus 1 is equal to 2x times 0.792481. I can now multiply this together. And when I do, I get x minus 1 is equal to 1.584963x. I now simply need to add 1 to both sides and subtract this from both sides. So I'll get x minus 1.584963x is equal to 1. Combine these like terms, and I get negative 0.584963x is equal to 1. And then I just need to divide both sides by that decimal. I'll get x is approximately equal to negative 1.709510. Just to make sure you're still with me here, you do realize this is the number that if I took it right back up here and plugged it in here, would give me a true statement. And in this case, I would say gives me almost a true statement because this is an approximation, not an exact answer, but it would come out really close. Well, that's all I have for you today with these examples. I really suggest that you practice these examples until you can do them successfully. Have a great rest of the day, and I'll see you again soon. Bye-bye.